Okay, so in this next section here, we move away a little bit from the algebra and think about geometry again. So we are going to prove that two triangles are congruent using SAS and SSS. And SAS stands for side angle side, and that means, of course, that SSS stands for side, oh boy, side, and by the end of the summer my handwriting will be decent with the mouse. I guess I have to try a little harder. Side, side, side. Alright, so first thing, side, angle, side. If two sides and the included angle, and that is muy importante, that the angle has to be in between the two sides that you know information about. That's what it means by an included angle. If you know that those things are congruent, then you know that the entire triangles are congruent. So that, boys and girls, ladies and germs, is the side angle side thingy. And then this is a fun thing, every geometry teacher's favorite acronym. Corresponding parts of congruent triangles are congruent, also known as cpctc, which means that if and we talked about this on Monday, if you know that two triangles are congruent, then you know the angles are all the same and the sides are all the same. So the beauty of this little theorem here is that all I need to know is two sides and one angle, and if I know that, then I get the other side, or the pair of sides I should say, and the other pairs of angles for free. And if I can get more information without knowing a bunch, then that makes me happier. Okay, so if I know that these two sides are parallel and they are also congruent, then how can I show that these two triangles are congruent to each other? So let's get a little bit formal here. We could say AB and CD are parallel, and that has been given to us. And then we also know that AB and CD are congruent, and that's also given to us. I'm going to say that AC is congruent to itself, and I know that by the reflexive property. Then I know that I should be more specific here, but I'm not, that angle A and, okay, I am going to be more specific here. I know that angle BAC and angle, what would that be, ACD are congruent to each other, and that is because they are alternate interior angles. And once I know that, then I know that triangle ABC and triangle, triangle A would go with C, B goes with B, and C goes with A. Triangle ABC and triangle CBA are congruent, and that's from side angle side. Therefore, I know that angle B and angle B are congruent by cpctc. Corresponding parts of congruent triangles are congruent. Okay? So to recap in English, since we know that these two sides are parallel, we know that these two angles are congruent to each other. These are the same length, obviously, because it's the same segment. And then I have side, angle, side, and I have side, angle, side. And so that gives me the two triangles. And then once I have the two triangles, then I have all the corresponding pieces. Okay? Okay, another one that we can use to show that triangles are congruent is side, side, side. If all three sides are congruent, then that means that all of the angles are congruent. That may seem like so obvious it's not worth stating, but notice that the same is not true for angle, angle, angle. So there might be a little bit more to this than meets the eye. So these two things obviously are congruent because all the sides and all the angles are the same. But if I stretch this out like this, then that angle is the same as that one, that angle is the same as that one, and that angle is the same as that one, but the triangles themselves are not congruent. So angle, angle, angle is a failure. Can't be done. Okay, so which of the following pairs of triangles are congruent by either side, angle, side, or side, side, side? This one we have all three sides, so obvi that's side, side, side. This one we have side, angle, side, so that's going to be side, angle, side. Okay. This guy, notice we can't tell for sure because the angle that we know is not in between these two sides. We would need to know this angle right here and this angle right here. And it might seem to you, viewers watching at home, that if you know these things, then the triangles are congruent as well. But that's not actually the case, because if you could visualize, I could take this side right here, and I could make a little isosceles triangle. Oh no, that's not going to work. I have to swing a different side. But there's a way for me to do that so that those don't necessarily line up. They could, but they might not. Okay, and then this one, these two would be congruent by side, angle, side. Okay. All right, what else would we need to know to show that these two triangles are congruent if we wanted to use side, angle, side? Well, we would have to show that this side is congruent to this side, because then we would have two sides and the included angle. If we wanted to show by side, 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 instead of side, angle, side, we'd have to know that these two sides are congruent to each other as well. Okay, is stew congruent to x, y, z? Yes, because this side is congruent to that side, that one is congruent to that one, and then I have an included angle that's the same, so that's yes by side, angle, side. Is any additional information needed to show that these two are congruent? Yes, because this angle that we know is not in between these two sides. We would either need to know, well, they want us to do specifically by side, angle, side, so we would need to know that angle F and angle J are congruent in order to use side, angle, side. This doesn't help us because it's not in between the two sides. Okay, so there are your first triangle congruence theorems. Congratulations. Here's some problems for you to work on.